Okay. So what we're looking at today is more of these word problems. This is similar to one that we saw on Monday when we were solving one-step equations. It says Samantha has some pieces of candy. I wish. She gave Denise 7 pieces of her candy. She has 15 pieces left. How many pieces of candy did Samantha start with? On Monday, we're looking at how you represent the story with an equation. And on Monday, we said there's 2 things we were looking for. We said we were looking for, do you guys remember?
The variables
of
the operation.
Woo, perfect. We want a variable, so we want to figure out like what that unknown number is, and then we want the operation. We want to figure out what math is it describing. I'm going to have you start us off. Do you know what the variable is going to be?
X minus 7.
So you're using x. Tell me what x represents.
The amount of total she have.
Yep. So we could say the amount total candy she has. What did you put for yours?
Number of pieces of candy Samantha has.
Number of pieces. How many? I'm just going to put number of pieces here. Anything along those lines. So amount of candy, number of pieces, how many candies she has. So we've got, you're using X. I know you use C. Does the letter matter?
No.
Nope. And then, so you gave me the variable. Francis, I'm going to have you give me that equation.
Take away 7. So X take away 7.
Yep.
Equals 15.
Nice. Tell me why we're using subtraction.
Because you're taking away from the number of pieces she had
So
from
now
what she
we
gave
have
you.
left.
Yeah, you both got it. It's the idea of like we're taking away from how much she has. It's saying that I gave. I think that word right there is a clue that I'm giving away. I'm losing candy. Once we've got our equation, the last part is just answering the question, how many pieces of candy did I start with?
22.
You said in unison. 22. I was going to say 22 candies. Tell me how you got 22.
You can either add 7 to 15 to get your answer.
Yeah. And that would give us x equals 22. Nice.
7 plus 7.
Oh, yeah, so we can talk through it more. The negative 7 plus the 7, what happens there?
Cancels out.
Yep, because it equals
0.
0. What we're looking at today is building on this idea of looking at story problems, representing it with equations, and then answering more questions with that. All of the word problems we've looked at so far, we represent with equations like this. This is a one-step equation. Can you guess what we're doing today?
2 steps.
Yeah! Say it with more joy in your voice. 2-step equations. So that is the focus of today. Yesterday we learned how to solve 2-step equations. And today we're going to get to see how they can be useful with representing these word problems. So I can represent and solve word problems using equations. This will also be a good review of 2-step equations, which I heard you were doing an excellent job out there with Denise. So to start us off, the first question we're looking at says, the new iPhone just came out and Sully can't wait to buy one. The phone costs $300 plus $30 per month for data. Write an equation that represents this situation. That's going to be our end goal. I've got a couple questions we're going to answer before we get to that equation part. My first question is asking, how much total money has he paid after 1 month? Tell me how you're getting that.
Because she's going to buy the phone
Mm-hmm.
for 300 and the 30 bucks a month.
Mm.
So she's getting the phone and the $30 a month she's getting together.
Mm-hmm. So that leaves us with the 330. The 300 for the phone, the $30 for that 1 month of data gives us, she spent a total of $330. What about after 5 months?
So you do 30 times 5.
30 times 5. Why am I doing 30 times 5?
because we don't know the exact amount, and we can do 30 plus 5, 30 and 5 places too.
So I like how you're switching through between those two. So we could say 30 for the first month, plus 30 for the second month, plus 30 for the third month, and so on. But you're saying we could just multiply 30, the $30 per month, times how many months? What does that equal?
350.
Not 350.
300.
Are we looking at this one?
150.
150. Yep. You can do 3 times 5, which is, and then all we have to do is copy that 0. So 150. Is that the total amount he's paid?
300.
Yeah, we still have that phone for 300. So this is just how the total amount of money he's paid for the data. So you mentioned 300. What you want me to do with it?
Do we still need to put in amount for phone?
Yeah.
She already paid, or we already paid for the phone the first month?
So if we're trying to find that total money spent after all this time on the phone, we've got the 300 for the phone, plus the $150 for 5 months of data.
450.
That's going to come out to 450. What about 10 months?
300 plus 300.
How are you getting 300 plus 300?
You should get 150 in 5 months, minus 150 times 2.
Oh, yeah. So we could do, so you know it's going to be 300 plus 300. Is there another way I could show that?
300 plus 30 times 10.
300 plus 30 times 10. Where's the 30 times 10 coming from?
$30 times 10 months.
Yep, the $30 per month times the 10 months. And then 30 times 10 is?
300.
Your answer you told me. So the total amount of money?
600.
600. In general, just like tell me a general rule. What are we doing in each of these problems? We're multiplying what?
Multiplying by 2.
So-
Multiplying per month by how many months?
Yeah, so you're multiplying that 30 per month times how many months? So the $30 times 10 months, the $30 times 5 months. I heard you say we're doing multiplication and addition.
Mm-hmm.
So we're always doing that multiplication, and then we're always adding what?
The 300.
The 300. That 300, notice, isn't changing. Every single time I've got that plus 300 at the beginning, the amount that's changing is just that total amount for the months of data. If I asked you how much total money is he going to pay on this phone, and I don't tell you how many months, what would the variable be?
Yeah.
M for, I asked the wrong question. I told you what it was going to be. M for the number of months. A number of months. If we want to know how much total money he's paying, every single time we've got that 300. Every single time we're multiplying by 30. The thing that's changing, the number that's changing that we would need to know is how many months he's got the phone. So when we go to write our equation, use everything we've been doing here to help you write that equation. What's the first thing we've been doing each time?
We multiply the month.
Yep. So you had said earlier, Francis, we're multiplying what by what?
The months, the price by month.
Yep. So you're saying we're multiplying the price by month. What is that going to look like in our equation?
Which one are we gonna use?
300 plus 30 times M.
Woo! Yes. How do you want me to write 30 times M?
Round parentheses.
Mm-hmm. I'm just going to pause you right there because that's great. You already went in and added that 300 there. So the 30 times M is what we were just saying. That is what we were starting off doing every single time, right? The 30 times the number of months. The 30 times the number of months. That's exactly what this is. The 30 times the number of months. Could I have written this a different way?
Yeah. 30 times M plus 30, 300.
Oh, so you're saying 30. How do you want me to write 30 times M?
Yes,
The parentheses,
Yeah.
the same way. I love how you brought that up. So notice it kind of goes back to what we were saying about equations yesterday. It doesn't matter the order you've got those in. They both say the same thing. I'm thinking specifically of how you show multiplication in equations.
You can dot.
You could use dot. Do you remember what we said? Like the most common way is you're going to see it?
Yeah. 30.
Yeah. We don't, what that says is correct. It says 30 times m. The most common way you're going to see it is just the 30m. They're all good. I do want to make sure you guys know that this is the same thing as 30 times m. So we've got, I'm going to start off with this one. We've got the $300 for the phone plus the $30 times however many months you've got that phone for. When I do all of this math, what does it tell me at the end? Yeah, the total amount. Right now, this is saying for any number of months. So I don't know what that total amount's going to be because it's going to change depending on how many months I've got it. So we're going to use another variable. You told me you use that word total. Let's use the letter T. And then I'm just going to write off to the side. T represents, yeah, total amount. You could say the total spent on the phone, the total amount of money Sully spends. You could have also used C if you wanted to say like the total cost of the phone. There's one letter we could not use. Do you know what that one letter is?
M.
Yeah, why couldn't we use M?
You can't use two together.
Yeah, M we already said represents, where is it? There it is, the number of months. So I couldn't also use M for something else. I say that because especially with this one, lots of times people want to use like M for money. M is already defined as months, so we need a different letter. And just like that, you've done it. Look, you've written, this is what Francis predicted, a two-step equation to represent this problem here. How are we feeling about this?
Okay.
The trickiest part with these is knowing when a number doesn't need a variable and when a number does need a variable. So before we move on, I just want to talk through that part. Why does 30 have m with it? Why did I need a variable there?
To represent the number of months that, because we didn't, if we don't know the months.
And then going back up to the math we were doing each time, what do you notice about the math we were doing with 30?
Multiplying by 5.
By 5 or by 10. It was a number that we were paying again and again. So we needed that variable with it because it was going to be multiplied. And you said if we don't know how many months, we need something there saying we're multiplying it by the number of months. Why doesn't 300 have a variable with it?
Because that's just the cost of the phone.
Tell me more.
Because you only pay the cost of the phone one time.
That's it right there. That 300, we're never going to multiply it by anything because you said it's a one-time cost. I'm always just adding 300 one time. It's never being multiplied. So if it's a one-time cost, we don't need a variable because you're not multiplying it. If it's something you're paying again and again and again, we're going to need that variable to figure out how many total times you've paid it. You guys did great. So there is one last question to this. And that, ooh, look at all the math. And that last question is, if Sully has $450 saved and spends it all on his iPhone, how many months can he have data on the phone? Tell me how you got that.
Because he's going to pay for the phone and the data for the 5 months. Except if he's not paying for the phone. If he's not paying for the phone, it's going to 15 months.
Okay. So you're saying you know he's paying
For the phone and he's going to pay for the Telegram.
But tell me some of the, like, what was the math you were doing to figure out the number 5?
For 5 months,
Mm-hmm.
I subtract 500 from 450. Then
300 from 450?
300 from 450, then I multiply the rest, then I divide it by 30.
And what did you get when you subtracted that?
150.
Mm-hmm. And then you said you divided that,
150 by 30.
and it gave you?
5.
Nice. Is there another way we can figure that out?
except if he's not paying for the phone. If he's not paying for the phone, he's gonna have 15 months.
So you're saying if he is not paying for the phone, but you were right the first time. He's paying for that phone, so we gotta include that in our math. I left this equation on the board. Do you see a way we could use this equation?
450 minus 300.
I'm gonna put the equation over here. As I'm writing this, remind me what this says. It says 300 for the phone plus 30. What's M?
Months.
Months equals, what's T? Total.
Amount.
When they say if he has $450 saved, they're giving us more information now. What did they just tell us?
Did he say $450
Mhm.
to spend on the phone?
He saved $450 to spend on the phone. What have they told us in relationship to our equation here?
The phone, the total amount of the phone, and the
Mhm.
total amount of the data used per month.
So they told us the total amount of the phone. They just told us our T. So if I've got this equation, if I know 450 is T, what could I do? Subtract what?
You do as a now?
I do what?
Is that what I'm going to do?
Yeah, if I'm telling you T is 450, if I want to use my equation and I'm telling you T is 450, what could we do?
$450 take away 300.
With the equation, what could we do?
We can have 2T.
Tell me what I should write. When we wrote this equation, you gave me two variables because there was two things we did not know. When you don't know the number, you have to use the letter. If I am telling you now, T is the number 450.
300 plus 30 times 5.
I didn't tell you 5. That's what we're trying to find. All I told you was 450 is our total.
So 30M equals 450.
Equals 450. What is that called? So we've been doing all week with equations.
Substituting.
Yeah, I was looking at you because you're the one who always gives me the word. It's that idea of substituting. If you know what the variable is, you don't have to use the letter anymore. You can change that variable to the number. If I'm telling you the number is 450, in order to find our months, we can switch out that variable, and then we've got an equation we can solve. Looking at that equation, using what we learned yesterday, how would I solve that equation? Hold on. If I want to solve for M, what do I need to do to solve that equation?
450, yeah, 450,
You do divide.
Nope. Yesterday we said when we have a two-step equation, where do I always start?
left.
With a constant.
Ooh, nice vocab. You both are right. On the left because what's also on the left side?
The price of the
Nope. The variable. You are always starting on the side with the variable because these are the numbers you need to get rid of. Francis told me the constant, which is correct. When you're solving a two-step equation, we're always going to start by getting rid of the constant. Which number is our constant?
300.
Yep. So how am I going to get rid of that?
You are going to subtract 300, and
Uh-huh.
that'll cancel it out.
It will cancel it out, which leaves me with
30M equals 150.
Yep. Notice, what's the first thing you were doing over here? The same math. We're just putting it with the equation now. What's the second thing you want to do?
Then you have to divide
Mm-hmm.
the number of months by 5.
Nope, this equation doesn't have 5 in it. What are we doing to solve this equation? If I want to get m all by itself.
And divide by 30.
Mm-hmm. And when I divide by 30, what happens?
The 30 cancels out.
Mm-hmm.
And then you're left with 30 divided by, 150 divided by 30 is 5.
Mm-hmm. So we get,
Bring down the m.
yeah, m equals 5. Notice the math here is the same as the math here. All we're doing is doing the same thing we were doing yesterday with solving these two-step equations.
So must we use this same equation? Like this solving?
For this problem, no. I just asked how many months, but you missed the lesson on this yesterday. I could give you an equation like this, no word problem. You've got to know how to solve the equation. We're lucky here because we've got a word problem. We can use what you did, right? You used some common sense to figure out the months, which is great. But you also need to be able to, if I give you this equation and ask you to solve, you've got to know how to solve it. With or without a word problem. This was one example. We're going to quickly go through the second one. There's less questions for the second one. And then I'm going to have you try one. For the second example, we've got Gafar pays $1.25 for a bus ticket. He will buy some snacks before getting on the bus. Each snack costs 75 cents. And again, our goal is we're going to write an equation to represent the situation. Before we get into these, tell me what's going on. We've got Gafar. What is he doing?
He's buying a bus ticket and snacks.
He's buying a bus ticket and he's buying snacks.
Yep.
What's some other information we know?
Because each snack costs, so it doesn't tell us how many snacks, just how much.
Yep. So I'm hearing you say we know the cost, but it says each snack. It says he's buying some snacks. So I heard you say we don't know
How much snacks he's buying.
how many snacks he's buying. So that first prompt I've got is what is the variable? You've just told us.
Snack.
So what should I could
S.
S, and we're going to say S is,
The amount of snacks.
yep. So you could say how many snacks, how many snacks he's buying, total amount of snacks he's buying, something like that. I'm just going to write number of snacks. Nice. I want to give it up for you too because this part here, oftentimes it can be really challenging and you guys are doing real great finding that variable in the problem. Equation time. We've got Gafar. You told me he's buying a bus ticket, he's buying snacks. Help me write an equation to represent this situation. What?
$1.25
Mm-hmm.
plus 0.75 times S
How do you want me to write that?
times
Times?
S.
We can get back to that in a second. So let's talk through some of the things you said. You said $1.25. I noticed you just got $1.25 by itself. Why isn't there a letter or a variable with it?
They already give us the number of it.
Yeah. They already give us how many? How do you know how many he's buying?
The $1 is for a bus ticket.
Yeah. Samantha's being the English teacher again. That means he's bought one. We know how many he's bought. So you've got that. Now over here you told me multiplication. Why would I want multiplication?
So you will buy some snacks.
Mm-hmm.
Snacks is product.
So why would we want multiplication there?
We don't know how many is They
Mhm.
already give us a fixed price, right?
Mm-hmm.
So it's gonna be multiplication like probably 2 snacks, 3. So,
Yeah, so however many snacks he's buying, he's multiplying it by, you use that word, that fixed price. And that would give us the total amount he's spending on the snacks. Last part you said we're adding those two numbers. Why would we want to add them?
no, this is separate. Yeah, the $1.50 is separate.
Yep, so they're two separate things. This is the cost of the bus ticket, total cost of the snacks. What are we finding by adding those two things together?
Total cost of what he spent.
Oh, so when we add those two together, it equals,
So,
Total cost.
there you go. So we could say T, and we could just say T represents, I heard Francis, you said total cost. This is a beautiful equation. If there was one thing I would want to improve even more,
Get rid of the multiplication sign and just put S by the 75.
love it. Let's just put the S there. Do you remember why we see this a lot more than this?
Because you don't need the X.
We don't need the X. It also looks like an X now that we've got variables everywhere. And I know you really like using X as your variable. Could you imagine if it said XX? Carlos isn't here to tell us. This is to help us make it look clean. Take out the unnecessary stuff. So we've got our equation. I don't want to take away, like, this is correct. This is saying what we want it to say. This is going to be the most common way you see it. And it's also going to help not get it confused with the letter X. We've got our equation. We've got more information now. It says if Gafar picks out, why is this chair here? Okay, let's try this again. If Gafar picks out 4 different snacks he wants to buy, how much is he going to spend on the snacks and bus ticket?
so it's going to be 0.75 times 4.
What's that equal? Well, 75 cents and 75 cents is.
30 and $3.
So this would be $3. 75 cents and 75 cents is
$1.50.
$1.50. So then if we double that to get up to 4, it would give us our $3. What do you want to do with those $3?
Add
Oh,
that
add it to the
$1.25.
1.5.
1.25? Yeah. Which leaves us with.
$4.25.
Okay. I'm going to push you now. Use your equation. What would it look like if we were using this equation to help us find this answer?
1.25 plus 0.75 cents times 4 equals T.
Nice. If I give you this, where are you going to start your math?
With
The parentheses.
What type of math is happening right here?
multiplication.
Multiplication. Why would we want to start here?
And
Yeah, it goes back to PEMDAS. Multiplication before addition. When we multiply, it gives us,
$3.
notice you've already done all this, the $3. I can copy everything else down. Last thing?
Addition.
Yeah, which would give us.
420.
So notice with the equation, you're doing all the same things you did here. It is a good reminder of how you solve these equations, so these two-step equations. The other thing, last thing I want to point out, is this equation and the one we did last time. They look different. Last time we had numbers on both sides and the variable with it. I wish I hadn't erased it. Was 300 plus 30m equals 450. Notice this is similar to the two-step equations we were solving yesterday. We had to start, Francis told us, by getting rid of our constant, then dividing to get m all by itself. This time, the variable was already by itself. We just had to do all of this math. Depending on the information they give, it could look like this, it could look like this. It's gonna just depend on what we know and what we're trying to find out. I could have told you he spent $425 total. How many snacks did he buy? And then it would look more like the equation we solved in that first example. Y'all are doing great. Do you have questions for me? it is that time then where you get to try your own. So you're going to try this one here about Brandy. Do you need to come in? They're
We got
trying
some
one.
visitors from the traditional high school. We just wanted to
Hello.
pop and see what it looks like over here for our Doors students.
We're very.
Always have something hanging from the ceiling.
In math classes.
I love
Yeah,
it.
that
Yeah.
sounds about
I
right.
like the
doesn't it?
vibe of West a lot. It's a
Well,
good job.
I know math isn't always everyone's favorite thing, so I try to make it look as colorful, as friendly as possible.
Good job.
Our lower
Yeah.
house, like our room is so dull. It's like
Our elder teacher, he does not know how to decorate.
I said it's probably good that the room is this small because if it was twice as big, it'd probably be overwhelming.
I think that's a good PD though. How to make math classes colorful and exciting.
Hang colorful shapes from your ceiling.
Thanks for letting us interrupt.
Yeah. Tell me how you're getting those numbers for A and B.
20 is the cost of cost of one shoe.
Mhm.
So 40 is the cost of two shoes.
Mhm. Is that the only thing you're paying for?
The entire order.
Go back a little bit. What is the $10?
I'll ship in for the entire.
So if you want to get those shoes to you, there you go. You're doing great. Yep. So now the fun part. What is the variable? Nice. So you added a new variable in. So tell me what that one is too now.
This one,
Uh-huh.
the total of the cost of the amount of shoes she gets and the shipping.
Yep. Where's this? I'd like to talk through the first couple. So this first one, how much would one pair of shoes cost?
$20.
Agree.
Plus 10.
Plus the $10. What teamwork?
30.
What about two pairs?
$40 plus 10.
Where's that $40 coming from?
2 shoes.
Two shoes. So if one shoe is $20, two shoes is $40.
Plus 10 is $50.
Why didn't we double that $10?
Because it says the total cost of shipping is $10 for the entire order.
Mm-hmm.
The $10 doesn't change.
Yeah. It doesn't matter if you're shipping one shoe or I guess one pair of shoes versus 10 pairs. It's always you notice it says the entire order. So it's not changing. So when we get down here, what is our variable?
S.
S. What's S represent?
Number of shoes that she wants to order.
Yeah. That's what's changing from problem to problem. Number of pairs of shoes. So you would notice the shipping staying the same, but what's changing is the total cost of the shoes, and that's going to depend on how many shoes you're buying. So when we get down to this equation,
20 times S, with the S beside the 20.
20 times
plus
S
10 equals 90.
equals,
Oh, no. Equals T.
yeah, I was going to say you're not wrong yet, but we don't know how many shoes yet, and that's going to affect our total. So we've got this. There's one last one I'm going to have you finish up on your paper. And I saw you were working on it. So you set it up like this. See if you can solve this equation the same way we were doing yesterday. I see you've got the answer. I'm going to have you practice that idea of like solving an equation. And people at home, I'm sorry, this is that last question. No, that's not solving an equation. That's just you putting in a number. It's the same way if you flip back to the one on that front page we solved. It's showing me those two steps you have to do to get S all by itself. So we've got this right here set up as our equation. If I want to solve for S, I know you both know what S is at this point. But we have to make sure if I give you this equation, no word problem, you know how to solve for it. There's two steps. It's what we did yesterday. In order to solve for our variable, where do we start?
The constant.
Our constant, and our constant is 10. Perfect. How do I get rid of the plus 10? Nice. Minus 10.
Minus 10.
Yep, on the other side too. When I do that, Francis, what do I get?
The 10s are canceled out, and that would be 90 minus 10 would be 80. So you bring down the S would equal 80.
20S would equal 80. Last step.
Divide.
Your voice has gotten so much higher. Divide What am I dividing by?
20,
Yeah, just the 20. We don't want S to cancel. We just want the 20. So the 20 divided by 20?
It's canceled out.
cancels out because it equals?
0.
No. What's
Well,
from?
equals 20.
No. 20 divided by 20 equals 1. So we get 1s. 1s is just the same thing
That's 1.
as s. So we get s equals 80 divided by 20?
4.
4. How many shoes can she buy?
4 shares.
Four pairs of shoes. That's so weird. 4 pairs of shoes, which is actually 8 shoes. There's one last example. You guys have gotten very good with these word problems. So this last one here, we've got Mercy earns $2 for each cookie she sells and $2.50 for each brownie she sells. Write an equation to represent how much money she makes selling cookies and brownies. So when I go to write my equation, I'm giving you a clue. There's going to be variables in it. What's one variable in this situation?
C.
So you're starting us off with 2c. You just use c. Tell me what c represents.
Each cookie
Mm-hmm.
she sells.
So describe it, making it sound like a number. C is
Total amount of cookies she sells.
perfect. We can write that. The total amount of cookies sold. You could say number of cookies, the amount of cookies she sells, total amount of cookies, how many cookies she sells. All of those are good. We've got 2c. Do you just want to keep going with the equation? We're writing an equation to represent how much money she's making. So you've got 2c right here.
Was $2.50 times B.
Ooh, so another variable. Ayo, can you help me out with B? What's B represent?
How much money she makes after selling? The total amount
The total amount of what?
of the cookies she sells.
Total amount. It's not cookies. 'Cause
Brownies.
yeah, total amount of brownies sold. I want to pause here because this is where it's a little different than the previous ones. Before we had only one variable, right? Here we've got variables on both sides, or rather with both numbers. Why did my 2 need a variable and my 250 need a variable?
Because it doesn't tell you exactly how many she sold, just that how much she made for each.
Yeah, so we know how much money she's making on each of them. So why would I multiply 2 times C? What's that saying?
I don't know exact number she sold.
C is the number of cookies she sold. So when you multiply 2 by C, what is that finding out?
The total amount of cookies she sold.
C is already the total amount of cookies sold. So when I multiply it by 2, what am I figuring out?
How many she sold.
No, the total.
So the total of something. If she
The
sold,
total amount of the money.
there we go. It's the total amount of money she makes selling all those cookies. This is how many cookies she sold. So let's pretend she sold 5 cookies. If I multiply it by the $2, then I'm figuring out how much total money she made on those cookies. Brownies, same idea. Same thing. Yep, the $2.50, the $2.50 times the number of brownies is figuring out the total amount of money she's making. So when we add up the total amount of money she makes from the cookies plus the total amount of money she makes from the brownies, that's going to give us,
450. No.
give me words. If we add up the total amount of money she makes from cookies plus the total amount of money she makes from brownies, what do I find when I add those numbers together?
Total amount of money she makes on both cookies and brownies.
Yeah, just the true total, right? The total amount of money she's making. So we could label that as
T.
T, where T is,
Total amount she made.
yeah, total amount of money made. Now I do want to go back for a second because every single time I do this problem, let me tell you, I always hear the 450. I always hear 450. Why can we not say it equals 450?
to show how much she made for each one.
Good. So if we say 450, that means she only sold one cookie, only sold one brownie. Let's talk a little more about it. Can I add these two things together?
No,
Why not?
they're separate amounts, separate item.
Separate items. Go back to what we learned about combining like terms. If it wasn't a word problem, if I just gave you 2C plus 250B,
They don't have the same variables or exponents.
yep, they're not like terms. They don't have the same variables. They don't have the same variables because of what you said. They're two different things. We can't add them up together. Nice. Once we've got our equation here, the last part, your favorite part, says Mercy made $55 on Monday and knows that she sold 10 brownies. How many cookies must she have sold? We've got our handy dandy equation. And they just gave me a bunch more information. What's one thing they just told us?
The total amount of brownies she sold,
The total amount of brownies she sold. What number is that?
10.
10. So we know 10 is our B. What could I do with that information?
You multiply $2.50 times 10.
Yay, love it. Is that the only thing they told us?
How many cookies she made 55 on Monday.
So what is that?
The amount of money she made on Monday.
Nice. So if we know that's the total amount of money she made, what could I do with that information?
So you after multiplying $2.50
Mm-hmm.
times 10,
Mm-hmm.
you minus it from 55.
Help me out with my equation. What can I use? How can I use this information with my equation?
55 minus.
You're jumping ahead to some of the math.
So we need. Sure.
2C plus 250
Mm-hmm.
times 10 equals 55.
Yeah, the same thing we did here. When you told me B is 10, ooh, there's the math word. When you said B was 10, we substituted 10 for B. Same idea. Francis said, let's put that 55 in for T. Now is the math. Now is the part you keep describing to me. So you said we want to multiply this and then subtract it from the 55. Let's do exactly that. What is 250 times 10?
$25.
Yep. Fun fact, when you're multiplying by 10, that decimal is just moving over 1. So we get 25. So we get 2C plus 25 equals 55. Now, a moment ago, you told me what the next step is going to be. Do you remember?
Yeah, 55 minus 25.
Yep. We're going to subtract that 25 on both sides. I am running out of room, so I'm going to bring it up here. Plus 25 equals 55. You said subtract 25 on both sides. What's that leave me with?
$30.
30 equals.
2C.
And I like how you said $30, so you're remembering that's money. Pause just right here. What does 2C equal $30 mean?
Usually multiply the 2 from the 3. From the 30. The 30 multiplied by 2.
30. You want to multiply 2 on both sides?
Yes. No, divide.
No? Why did you switch to divide?
Because you're doing the opposite of what it is.
Nice. So you had said a moment ago this is multiplication, so we want to divide. And that gives me C equals
15.
15. What does this say? If C equals 15, what does that mean?
That she sold 15 cookies.
Yeah, C is the amount of cookies she sold, so it's saying the amount of cookies she sold is 15. I had asked back here, what does 2C equal 30 represent? What that line is saying is if she sold 15 cookies,
$30.
yeah, you had told me this means she made $30. And earlier, I think it was you said this represents the amount of money she made from the cookies. This is saying the amount of money she made from the cookies is $30, which means she sold 15 cookies. I bet your brains are exhausted. I've got one last one for you, and then that will be the end of class. The last one is this one about school supplies. It's all for you. Goodbye, people at home.